Hello, Austin. Glad you could make it.
Hello, can you hear me?
Yeah, Austin, how are you?
I'm good.
I'm just getting things ready. I'm hoping that this camera thing I've got will work. I've been having it out with it.
Are you?
Yes. We don't always see eye to eye. I wanted to do that on its own projection. All right. Did you get the, oh, let me see if I can find it. Until I get this thing working. Did you get this?
Yeah, the syllabus. Yeah.
Okay. And I don't know why. Oh, it's going weird. We still have a few more minutes. How are the problems going for you?
They're all right. Be easier if I was in class, but
Oh,
I'm
yeah,
trying.
tell me. It'd be easier on me, too. I was throwing things yesterday. This
Were
machine made
you?
me so mad. See, it's just not working at all. You can see it over here, but I don't want it over there. Okay. Do you see the revised schedule on your screen?
I do.
Okay. There's a time delay, and I don't know if this computer I've got is old.
Uh-huh.
So I don't know if that's the issue or what.
Is the final over everything?
Yes, it is. Yeah.
Sorry.
And I'll be sending out review problems on that in the my math lab. I think I've got a review for the final. If not, I'll get it in there. But there's a review for the get this down a little bit. There's a review questions for chapter 12 and 13.1 that we'll look at on the 22nd.
Okay.
But it is in there. Hey, Will. You there, Will? Derek? Hey, guys. So far, I've got Will, Ben, Austin, Derek. Hey.
Hello.
Hello.
I was telling Austin a few minutes ago, I was throwing things yesterday because I got mad at this camera. I'm going to wait a few more minutes to see if anybody else comes in. Hey, Daniel.
Hey.
Everyone should hopefully have gotten this. This is our revised schedule. So we'll be looking at 12.4, maybe 12.5 today, depending on how it goes, because normally I usually do both of those in one day. Now, for this to work, you all do need to look at my lecture, okay? You need to do that because, like it says on here, homework questions regarding the sections below. So that's how we're going to have to run it, because I can't do a full-blown lecture on this thing because I'll get angry and I'll throw something. It takes me a bit to get to that point, but I do throw things. Hey, Peyton. You got the pretty Gatlinburg view. Now, 3 of you all were not here the other day, Monday. Hopefully you got this, because this is our revised schedule. And this is about due dates and the quizzes and the test. And down here is our Zoom schedule. So hopefully you were able to look at the video that goes with 12.4, maybe 12.5. I know some of y'all weren't here the other day, and I suggested you look at that. So I might say something about it anyway. Yep, we'll go ahead and get started. We might have some people come in a bit. Let me move this. On page 9 of your handout, these are just a bunch of more problems. The answers are on page 10. The more you practice these, the better you get. That's bottom line. So you've got problems, you know, in the homework and the quizzes, and here there's 30-something problems. And like I said, you're going to have to use this on every bit of the test. And over half the test is just doing this kind of problem. So you need to get, you know, get ready, get used to it. So are there any problems you all want to see? 12.1 or 12.2? Or 12.4? Peyton, have you got something?
Could you do 12 on the one page with a bunch of questions, page 9?
This one?
Yes.
Yeah. So there's my original problem. You have got to be able to get it back in the form like what we did in chapter 10, where you have your coefficient, then your variable, and in this case, dx at the tail end. So I'm going to move x to the 4th up to the numerator. And when that happens, remember that becomes a negative exponent. Let me switch to another pen. Now it's in the correct form for my first rule. When I start doing this, the integration sign stops because I am going in reverse. I'm going to put my coefficient over the fraction bar, write down my x. Remember, you have to add 1 here. Me adding 1 would give me a -3. I repeat there and tack on the plus c. I would leave it like that. The book might take it down, but this in this form, it's quicker for me to check and get the derivative of that to see if I've gotten the problem correct. But if there's any variables in the denominator, you got to move them up. So if that one's all right, how about another one?
Same page, 28.
Move it down a little bit. Now, in the first section, we had a rule for this one. We had a rule for x to the -1, which means natural log, and we also had e to the x. If I don't have e to the x, this is where I have to use substitution. So I'm going to now I know in the substitution part, the ones with parentheses raised to powers, you knew where you had to go look to find out what u was. Well, if it's not nice little old x, I go to my exponent. So u is going to be 3x squared plus 4. Let me get the du over dx. So is that all right so far?
Yeah.
Because now I'm ready to start substituting. I still have my x. This now becomes just e to the u, which is what I wanted. And then this becomes du over 6x. The x's eliminate. If you have a variable in the denominator over here, make sure it stays down there, but you need to bring it out front because it's a coefficient. So is that all right so far?
Okay, yeah.
Because once you get this down to this point, this is the nicest problem you could ever face. Because if you remember, e to the x was its own derivative. Well, it's its own antiderivative. So my answer here is 1/6 e to the u plus my c. But remember, because we had to use the substitution principle, let me go back and get what u was. And that would be it, Derek.
Okay.
I really like I like the e's because they are so quick. But those are the ones you won't see the parentheses. So you've got to, if you see an e, and if it's something other than nice little old x, where I could immediately go ahead and get the antiderivative, that's your clue right there. I've got to let that be u. So how about another one? 12/5 is dependent on you being able to do this. Integrate, get the antiderivative. Dependent. Any others, guys? Because I like these problems. If I can't sleep, I get up and I do calculus. It relaxes me. All right. So if you haven't looked at those problems on page 9, then you need to try those. Let me look at 12/4 just a second. Now, I don't know if you were with me the other day when I was talking about the integral sign. I said it started out as an S, and if you pull the ends in those directions, it becomes an elongated S. And guys, what this does is it sums up the area under a curve. It's always from the curve to the x-axis. Now, this is a method that you can work by hand where you get rectangles, but there's some things I need you to see here. First of all, the width of every one of these is the same, and the width is dx. Every one of my little rectangles here, the width is dx. The height is dependent on whatever my curve is. So if I know this x value, which I should, I would know this width. I could put that x value into my curve, and I can find the area of these rectangles. Now remember, the area of a rectangle is length times width. So when I have this form, this is my height, that's my width. I'm summing up all my little rectangles. The more I have, the better approximation I get. But the problem with just using rectangles, do you see these sections under here that I'm making solid?
Yeah.
Those are left out if I'm doing just plain little rectangles. This is called the left sum because the rectangles are attached to the curve on the left-hand side. In this particular curve, me doing rectangles on this, I would underestimate the area. This one, if you'll notice where they're all attached to, is on the right-hand corner. But the problem with this one, do you see all of these little rectangles? Where this one underestimates, this one on the right overestimates. Used to, in other books, we would do these type of problems. We'd get the area using the left sum method, get the area using the right. We would add them together and divide by 2 to get an average, because these right here that I've colored in closely fits in with the ones there. So it's a good way to estimate the area or approximate. But this takes too long. Does it make sense if the more rectangles I have, the better my approximation? If I could draw more rectangles, wouldn't it be a little bit better if I had a few more in here? It would cut down on my error. And so those pieces that I've colored in up there would be a whole lot smaller. But again, I don't want to do it this way. In this particular section, they're wanting you to get used to some rules. And hopefully you can read yours a little bit better than mine, because mine's sort of blurry. If you go, now this, let me back up here. The title of this section is a definite integral. When you have values, which we have not had that. In the first 2 sections, we didn't have numbers here and here. The A is considered the lower limit, B's the upper due to location. And it's telling me what my interval is. I'm going from A to B, and I want to find the area under the curve just between those 2 X values. Now in this first one, I want to find the area from A to A. I need you to look at this and understand what's going on. Say I have this curve, and that's A. Guys, A right here is just a line. A line has no area. I actually have to be able to go up somewhat in order for me to have some area. I have no width here. So if my width is 0, then 0 times whatever that Y value is would be 0. I'm also going to show you how to work some of these on the calculator when we get there. This is an important rule, especially in this section. If I go from A to B and it goes in that direction, I'm getting the area. But if you'll notice on your sheet, if you go in the reverse direction from B to A, notice it changes sign. If your A is on the left and B is on the right, and you go from lower limit to upper limit, it will be positive. But if you reverse direction, it becomes negative. This particular rule we'll use more in 13.1. And what that's talking about there is if I have myself a curve, I've got A here, B here, and say I've got C in the middle. Now I could go straight from A to B, but I could also go from A to C, get that area, and then go from C to B, get that area, and I can add. But again, this is more in 13.1. That's where that one's going to be. So let me get some problems out of the book. Because there's going to be a few of these on the test. I don't know if I can come in any closer. This is on page 735 of your book, if you want to look there, or if you can see it. It's not great, but they've given me a curve. They want us to calculate the definite integral by referring to the figure with the indicated areas. I'm going to look at the even ones so you can have the odd ones to play with. Over here on the side, which you can't see, it's sort of blurry. Let me write those up here. And I'll pull it down in just a minute. Okay, so those are my areas. Wish I had a better camera, but I don't. Maybe if I cover that up just a little bit. Now, guys, right now, a couple of things why I looked at the rectangles. They want us to calculate the definite integral by referring to this figure. If I made little rectangles in this big section A, it would be positive because my dx is always positive, but my y's, which tells me the height, can be positive or negative. So for area A here, if I go from A to B, my answer would be 2.817. My B here, notice it's below. My y values would be negative. So if I go from B to 0, my answer for that would be negative 4.951 because of the location. Going from 0 to little c, which is the big area C here, it's above. My answer would be 10.667. D, it would be negative. It goes from C to D. So my answer for that would be a negative 3.584 if I'm integrating. Now, problem 32 is this. Going from 0 to little c. Now, these capital letters refer to the areas with respect to the curve. These are lowercase letters. So 0 to c, it would be a positive 10.667. Would you be all right with that?
Yeah.
$34. Let me put this 10.667. So that was 32, 34. B to D, f of x dx. Well, I need to find the lowercase b, which is right there, and I need to go to lowercase d. Lower limits b, upper limits d, so I am going to my right. So whatever the areas are with respect to where they're located is what I have to play with. So I have to get capital B, but capital B being below, it would be a negative 4.951. I'll do it this way. I would add on C. And I've got to go all the way to D. D being below, it would be a negative 3.584. I would add those up. If I type this in right, I come up with a positive 2.132. So let's see how you in this game is going. Let me write down 36, and I'd like you to try it. So that's 36. You've got your areas over here to the side. I think I'm just going to call that area, and we get a little bit more room. Try 36. Let's see what you get. Do you have something?
Yep.
Do you have this? 7.083?
Yep.
Yes.
How about the rest of you all?
Yeah, I got that.
Guys, there's about 3 or 4 problems like this where you understand the direction and what you have to do. All right, let me go get 38. See, that was 7.083. Now, 38, look what your lower limit is and your upper limit. I'm going from D to A. I'm going in reverse. What that does is it changes all the signs. D will become positive, C will become negative, B will become positive, and I've got to go all the way to the end, and A will become negative. That's what going in reverse does. So let me try these. I'm going to have a positive 3.584 minus 10.667 plus 4.951 minus 2.817. I came up with a negative 4.949. When you calculate a definite integral, you can come up with negatives. Is that all right? Does that make sense?
Yes.
All right. So let me see if I can be quiet. Let me put 40 down here. Let me move it up. Try that one. Need any more time? All right, not hearing anything. I came up with a negative 8.533.
Yep.
So pay close attention to direction. This one, you're going from right to left. All areas change sign. So we've got one more. I came up with this. So Daniel, Will, you guys, Austin, how y'all doing?
I got that too.
I got
Okay.
to, yeah.
Well,
That's
good. Now, if you will practice the odd ones, you know, either from the book or in my math lab, guys, there's going to be some of these on there. And so that should be fairly easy if you understand direction. And there's only one more thing I need to caution you on. Again, these values are the X values. They have nothing to do with the capital letters. It just tells you which ones, like from little c up to B, it just tells me which ones I have to account for. So be careful with that. So you've got those problems you can play with. Let me see if I can find something else. All right, I'm going to show you pretty much what you have to do in 12.5. You've got everything in your tool belt that you need in order to do this. This is called a definite integral because I have an upper and a lower limit. I am going left to right, okay? But whatever unfolds here is going to do it automatically, algebraically. And I don't have to, you know, draw the curve. I don't have to do any of that. Your first job is to integrate. Don't worry about these numbers yet. They come in the second step. So what I need you to do right now is integrate x to the third, get it back to what it used to be. Whoops. So if you did that, your coefficient is 1. x2, I need to add 1 and repeat. I'm going to tack on the plus c. And once I've integrated, you need to make just a vertical line indicating lower limit and upper limit. Now, The next thing, I need you to make 2 parentheses with a subtraction in the middle. What we do here is we substitute the upper limit into this, and it goes here. This is when x equals 4. Back here, we substitute the lower limit, x equals 0. Actually, we can do this one without the calculator, because if I put 0 in this, I'm just going to end up with a plus c. Would you agree with that?
Yes.
Is everybody else?
Yeah.
Yes.
All right. So now, when I substitute, remember, I use my calculator. So I'm going to store 4 in. So if I put 4 here, I'm going to have 64 plus c. Is that all right? Did y'all get 64?
Yeah.
Yeah.
All right. Now I need you to look just a second what's going to happen here. I've got 64 plus c minus c. Guys, this is always going to happen. When I have a definite integral where I've got numbers, I'm not going to do this anymore because it will always cancel out. My answer on this problem is just 64. So you integrate and you substitute. Now, on page 12, I've got a lot of problems, but this is called the fundamental theorem of calculus. Your function is going to be continuous, defined on a closed interval from a to b, and capital F is the antiderivative of little f. Then, if I've got the definite integral from a to b of f of x dx, we integrate. Substitute upper limit minus lower limit. So this is the steps to use to complete the fundamental theorem of calculus. First, integrate, then do your substitution. I like the parentheses. I've always done the parentheses. Now I'm going to show you something on your calculator. Do you have your calculator?
Yes.
Yes.
All right. So we have to do this 2-part because I've got, you all have some of the new math type in your calculator and some of you don't. So just hold on a second. If you do second math, no, I don't want second math. Sorry, just press math. We had in derive. Do you see number 9 where it says function integrate? And Derek, I think you've got an 83, so yours should be in the same place.
It is. Yes.
So I'm going to press 9. If you have the new operating system, can I get this any higher? If you'll notice, it looks exactly like the original problem up here, where I have to put things. I need a box. Maybe I can use this. Yeah, it's so-so. But I'm going to press lower limit, press my upper limit, put my function. If you'll notice, it looks exactly like this, which in the new operating system, it's very nice. If you press enter, you can check yourself. But some of y'all, again, weren't here on Monday. On this test, I need to see work. I need work for credit. Okay? So that means when you get done with your test, you send it to me. Now, Derek, on yours, let me change my calculator back. Classic. All right, so second, why do I keep doing that? Math, number 9. Yours is a little bit different.
Yeah.
It says function integrate. Well, I believe we have to put the function in first. We got to do a comma, do an X. Remember that DX we had? But now
Yes.
you got to be careful here. If you remember in that other operating system, it was blinking on the lower limit. When we do it by hand, we do upper limit minus lower limit. But when you put it in the calculator, you have to put it in lower limit, upper limit. And let's see if I put it in right. Yeah. So you're having to put in the same information, but what they have, which is nice, is they've got this to look at. So they have to put in lower limit, upper limit, the function, and then back here, what the variable is. But we have to put in the same thing. You have to get used to your own calculator.
Okay.
All right. Let me look for another one. We're going to try maybe 1 or 2 more. I just have to get my book back together so I don't end up from one end to the other. All right. I'm going to look at problem 19. The directions on this is to evaluate. And once we do this one, I'm going to show you something else on the calculator that's cool, which I actually prefer over that other thing I just showed you. All right. I have to keep the numbers, but the first thing I need to do is worry about integrating. So x to the -1. What is it?
ln x.
Yep. So natural log of x. I'm not putting the plus c. Right after you integrate it and put your limits, do 2 parentheses. This one will be the upper limit. This will be the lower limit. I'm writing this so you'll remember what goes where, but I'm going to leave it up to you if you want to put that. So if I put 3 in here, I'm going to have natural log of 3 minus natural log of 1. Now, if you remember, natural log of 1 is just 0. So an exact answer here would be natural log of 3, but if they want a decimal approximation, I'll go to 4 decimal places. So you integrate and you substitute. I'm going to show you something else on your calculator. And I really like this. I just wish I had something else. Well, you move that up. Let me bring my calculator back in. Now, this time what I'd like you to do is go to y equals. And I want you to put in the original function, just 1 over x. I'm going to do second calc. Do you see number 7? Now, guys, in number 7, that tells me the f of x, I have to put in the original problem. I want it as similar to that as I can. So I'm going to ask it to graph. So let me do a zoom 6. I wish it were clearer, but it's just not. If I do that, that ain't much better. Well, anyway, do you have it graphed on your calculator?
Yes.
Yeah.
All right, so if I do second calc number 7, notice it asks me for the lower limit. I'm going to type in 1. That asks for the upper limit, I'm going to type in 3. And I don't know if you can see that answer. Does that look like what we had just a second ago?
Yes.
Here, I'll move it real quick. You ready? I actually prefer this because I like to see the calculator color. It also tells you not only the answer, but what your limits are from 1 to 3. So you've got 2 different ways that you can check yourself via a calculator. I think that's cool. Questions?
Okay, I had a problem with the graph, trying to get mine to graph. Oh, never mind. I just figured it out.
What'd you do?
I have no idea. I think I had the zoom off, maybe.
Have you got it to work?
Yes.
So you did second calc number 9.
Yeah, there it is. Now I got it. Yeah.
Good, good, good. All right, guys. What is Friday? You know, I don't have enough room in here. I don't know where hardly anything is. Well, I think we're supposed to be looking at problems for section 12.5 on Friday. I can't believe I already lost that thing. Did I put it back? Nope. Those of you that have that revised schedule, is it 12.5 we're looking at?
On Friday.
On Friday?
I think so.
I don't know where mine is. Weird.
Yeah. I've got it pulled up here. Yeah, the 17th is 12/5.
Okay. So you've got a little bit of a heads up. You need to be able to do them by hand and also know how to check yourself. Okay?
Okay.
So are there any questions, guys?
No.
I'm good.
I have one thing.
Okay.
Why on 19 did you not add the C, but on the one before it you did?
Because if you add the C here and here, what's going to happen is you're going to have natural log of 3 plus C minus natural log of 1 minus C. Peyton, those
Okay.
C's are always going to cancel.
So you just skip this step.
Yep, because I don't
Okay.
need it. Yeah.
Okay.
But I mean, it
That's
doesn't
it.
hurt if you put it in there, they're going to cancel each other out anyway.
Yeah. Okay, that helps.
Okay. Are there any other questions, guys?
Nope.
Well, make sure you get whatever you want to see with respect to 12.4, 12.5, and we'll do a whole bunch of problems. And then if I have time, I might say something about 13.1. But quizzes, the quizzes for the, let me see, chapter 12, they need to be done by Sunday. So make sure you bring your questions so we can take care of that, and you'll be able to get those quizzes done.
Okay.
Okay? All right, guys, I guess we're done. If you have any questions, let me know. I'll stay on here for a few minutes.